All right, so here are our last notes of the year. But you'll notice in the homework, we have 2 assignments. So you're going to do 2 days worth of practice on this. The first one is to add polynomials, and you'll attach that there. And on Thursday, you will be subtracting polynomials, and there's the presentation for that. So make sure you're noticing those 2 separate days. So you've actually done several of these before, which is a nice sort of way to end it. Try not to do something super crazy new on the last week. But now you know that this that we see here is a polynomial. 4a squared plus 3a plus 1 added to 5a squared plus 2a plus 3. Now remember, when we add polynomials like this, the like terms are the ones that have the same variable and the same exponent. So what I always recommend that you do is first, if you have anything in here, distribute. That distribution is going to come in handy when we start looking at negatives. Then you're going to want to use the commutative property to rearrange terms so that they're together. This is a step that some of you might not do. That's all right, but if you're stuck, make sure that you are going back and doing this step if you skipped it and then you get the wrong answer. And then the last thing we want to do is just simplify. So here we don't have any terms that we need to distribute. Everything's all positive. So I can just write it all out as one really long polynomial. Now, let's identify those like terms. Same variable and same exponent. So I've got 4a squared and 5a squared because they both have an a and they both have a square. 3a squared and 2a squared because they just have a. You can think of it as a to the first if you like to think about exponents. And then lastly, we have our constants, 1 and 3, which don't have any variables at all. Those are our terms. If you want to reorder them, you've then got 4a squared plus 5a squared, 3a plus 2a, and 1 plus 3. And so our simplified version, we're just going to combine the like terms. We don't have any negatives here, so our life is very straightforward. 9a squared plus 5a plus 4 is our final answer. So this should feel pretty familiar. This is the addition section, skip 27. Subtraction is where it gets a little bit harder, so we'll do 2 of those. So here we've got subtraction, which I'm going to think of as a distribution problem. I've done this before with all of you. And so when I distribute, I've got x cubed minus 2x squared plus 5. And then this becomes minus 2x because a negative and a positive. And then plus 5, right? Because a negative times a negative equals a positive. Now we've got a couple of like terms here. We've got our x squareds. We have our constants. But this x to the third doesn't have an extra buddy, so we don't need to worry about reordering. Do x cubed minus 2x squared. And then you'll notice here that this x squared term also has a negative on it, so make sure that you're bringing that negative along. Plus 5, and then the 5s are both positive like that. Now, just simplifying like terms. Again, the x cubed term, it has a 3, so it can't combine with these x squareds. So you get negative 2 minus 2, which is negative 4x squared plus 10. Now, we'll look at one last version that is slightly more complicated, something that's a little bit new. So here we see that we have 2 different variables, and sometimes those variables are in terms together. These rules still apply. Like terms still have to have the same variable and the same exponent. If they have to completely match if there's more than one variable. But this first thing, just going to make sure that I distribute. I only have one negative, which is this little friend back here. Distribute and rewrite. So you'll notice here I did some simplifying with negatives. So this is negative 1. Negative times a positive is negative 6. Adding a negative here is a negative like that. Now we want to identify our like terms. So first I'm going to see, okay, well, I've got an a squared here and an a squared here. These are familiar. I've got two constants here, right? These are an excellent set of sets. There's one more set, and it's these three, because they are all AB terms. They have the same variable, they have the same exponents. You'll notice that a squared b squared does not go to this group because it has squareds, whereas these are by themselves. You'll also notice that a squared can't go with a squared b squared because it doesn't have a b. You're looking for perfect matches. So when I rearrange them, I'm going to leave the 3a squared b squared by itself. And then the a squareds, if I want to do those next, that's 2a squared plus a squared. Now you'll notice that these terms are negative, so make sure you continue to make them negative. So minus 5ab, minus 3ab, minus 6ab, then the constants minus 2, minus 1. Then simplify those like terms. Again, really making sure you're paying attention to negatives. The a squared b squared term by itself. 2a squared plus a squared is 2 plus 1, so 3a squared. Negative 5 minus 3 is negative 8, minus 6 is negative 14. ab, you'll notice that these terms are staying the same, just like the way that we defined them when we were identifying the like terms. And then the constant minus 3. And there we go. That is our final set of notes for Intro to Algebra. Please let me know if you have any questions. I'll continue to be available and talk through things for the final, as well as any questions on these materials. Please get in contact with me in the comments, through email, or on Zoom. I look forward to hearing from a lot of you in the next couple weeks. Have a good day. Bye.